We'll get started in just a minute. Got 11 people in the class right now, so let's just wait on a few more people to show up. Okay, hello everyone. Hope you all had a good holiday weekend. First order of business here is that we have an exam scheduled for Monday, and I'm going to officially move that to Wednesday. I had my Tuesday, Thursday class yesterday, and we just barely finished 5.5. So y'all are at the same place. We'll probably just finish 5.5 today. And so I think it'll be better if we just Monday start 6.1, and then we'll have the test on Wednesday. All right. But I will give you, since we're not going to meet again, I'll talk a little bit about the exam so you can start to review. So just make sure you stop me 5 minutes before class ends, so I can just kind of tell you what the types of questions that have appeared on other exams I've given. And with that said, are y'all ready to get into substitution some more? Any questions? We're good. All right. So what I did here is I went to a website, because if you look at the problems that I've done on my homework solution videos for 5.5 on YouTube, I pretty much did all the problems out of the book for section 5.5, which is use substitution. So I didn't really want to go through any of those problems again, because I've already gone through them, or already have videos of those. So I just went online and I just looked up, integration by substitution, and someone had out there a list of problems. I think there's, let's see, 17 problems here. And so I thought it would be a fun exercise to go through some problems that I haven't done. And that way, if I run into any issues, you'll see that happen and kind of just see how it goes. What do you think? Yeah? Because that's kind of what it's going to be like for you. Every problem is fresh and new. So we're going to start out here with problem number 1. I'll just copy this over and put it on a new page for us. And then I'm going to be calling on people as we go here and asking for help. So remember that the most important thing here is that you have to be willing to fail. All right, you have to, what's the saying? You can't win the lottery if you don't play, right? You can't hit a home run if you don't take a swing, all right? So everyone's got to be willing to take a swing, try something, right? The steps that we went over last class are over here on the side, right? This right here. So the idea here was that when we're doing use substitution, we want to look at the integrand. We want to try and find something, okay? We need to be able to see something within the integrand, and hopefully we can see its derivative somewhere in the integrand also. There's a few things though about that derivative. The derivative cannot be in the denominator. The derivative cannot be trapped in a square root or inside parentheses being raised to a power. So derivative's got to be free in the numerator. And it's okay if the derivative is off by a constant. So let's say that you pick your u, your something, to be x squared. Well, it's okay if you see 5x, right? It'd be great to see 2x, but it's okay to see 5x because you're just off by a constant. So once we've established that, we pick our u and we let u be that something, and then we just go through this procedure. All right, so here's our first example. And I also want to point out that we're looking at this integral here. Right now, we only have a few things on our plate, like in terms of what we can do. We can do stuff from calculus if we know it, like if we see it, like antiderivative cosine would be sine. If it's x to powers, we can handle that. If it's x to powers by themselves, right? Separated with addition and subtraction. Other than that, we have nothing else except u substitution. And I'm bringing this up because not necessarily exam 1, but exam 2 is probably one of the harder exams, because I'm going to give you integrals and you're not going to know what method to use. And we're going to have 5 methods. So that's what makes it challenging. It's that recognition of, okay, I've seen something kind of like this. I'm going to try this. And you pick one of your 5 methods. So we're kind of, it's good that we don't know a lot right now, because this kind of has to be u substitution, but it's going to be, that's going to be a problem later. All right, enough of me yapping. Here we go. So I'm gonna do the first one, then I'll start calling on people to do the next ones. All right, so for me, I'm looking and I see here, in parentheses, I see this x squared plus 5x. And I know that the derivative of that is 2x plus 5, and that happens to be right there. I mean, this is about as clean as it could possibly be, right? I see something in its derivative. That derivative, right, this thing in blue here, is in the numerator, right? It's in the numerator. It's not trapped under a root, right? It's not being raised to a power. Everything's beautiful. It's great. In fact, I could even write it like this. And just peel it off to the back side like this. And now it's really kind of obvious that this is going to be my u. And then this right here is that derivative, right? Okay, so with that said, let's do this. I make a substitution. U is equal to x squared plus 5x. I take the derivative of u with respect to x, and that gives me 2x. Now the next step, I'm going to do this every single time I do a u substitution. I'm going to multiply both sides by dx. Now the reason for that, why y'all didn't stop me, 2x plus 5. I'm going to multiply both sides by dx. The reason I'm doing that, multiplying both sides by dx, is because what I'm trying to do is to get the stuff over here to match and substitute into my original integral. So I'm trying to do a substitution. That's the whole name of the method, u substitution. I'm trying to somehow transform my integral from being in terms of x into being in terms of u. So now I go and rewrite the integral. So I know I'm going to replace this part with u. So that's just going to be u to the 7th power. Don't forget that 7th power that was up there. And then, luckily for me, look at this. 2x plus 5 dx is exactly 2x plus 5 dx right there. So that's going to be replaced with du. So I just write du. And now we're ready to see if we can find the antiderivative of this. Notice it's in terms of u now. And so this is really just asking the question, do you know the antiderivative of u to the 7th? And that we can do because that's a power rule. This is just 1/8 u to the 8th plus some constant. So I've had many students ask me this in this class and the other class, what happens to the du? Like, where does that du go over here? And the answer is it doesn't go anywhere. The du is rather difficult to explain, like what it is. And right, Coleman and I spoke for like at least 45 minutes before class in my office hours, and it's still difficult to explain. So I don't want you to try and overthink it. For now, the du is just a placeholder. It keeps track of your variable. You're focusing all your attention on this part right here, finding the antiderivative using the power rule, and just remembering you have to always do plus c when you find the antiderivative. All right? Now we're not done because our answer is in terms of u. We need our answer in terms of x. So we have to go back and replace u with what we said it was, x squared plus 5x to the 8th plus c. So that's our answer. Now we could check our work, right? Couldn't we? We could check our work by taking the derivative. So if we took the derivative of this, we should get back the original integrand. So I won't do it, but if you take derivative of that, you should get right in here, this box right there. Okay? Any questions on that first one? All right, let's go to the next one. Problem number 2. And let's see. Is German around today? I see you there, but you're not outside in the backyard today. No response yet?
Yeah, I got it.
You're there?
Yeah.
Okay. You doing all right today, German?
Yes, sir. It was just my microphone.
Okay, that's fine. It's okay with me. So are you ready to go for this one?
Yeah.
Okay. Don't sound so excited.
Oh, yeah.
All right, so you got to take a swing. Do you see something in its derivative? Or, you know, maybe I should back up, German. Can you do anything like other than substitution? Can you do like?
Right now, we cannot substitute it. Or
Yeah.
we can just put the 3 minus x10. We can change it into u.
Okay, so what do you want me to let u be?
3 minus x to the 10th.
You want the whole thing?
Yeah.
Okay. All right. Okay, so everyone, what German has decided is to make all of this u, okay? Now, German, if you do that, now you have to take derivative of this with respect to x. So, German, what would be the derivative of that with respect to x?
It could be 3 minus x. That's it.
If you're taking derivative, you're going to have to do chain rule.
Oh, so it has to be
right, that 10 has to come down.
front, yeah.
10
to the 3 minus x.
To the
9th.
To the 9. Chain rule times derivative what's inside.
Yeah, 3 minus
is -1, right? Because derivative of 3 is 0. Derivative of negative x is -1, right? Yes?
Yeah.
Okay, now let me ask you, German. The method, go back over here and look at this method. The method said that you were supposed to try and find something, okay, which you did. Here's your something. And you also need to be able to see its derivative. So here's its derivative. Do you see its derivative anywhere in there?
Nah.
No. So what do you think that means, German?
That we're still not done.
Yeah, we're still not done, but more than that, we need to start over. That means that your choice of u doesn't work. Does that make sense?
Yeah.
So what happened, and let me tell you what the mistake that was made, is that you picked too much. You picked everything. And because of that, the chain rule gave us a derivative that was a bunch of stuff that you don't have, right? And you're not allowed to look at this anymore. Like, this is off the table because that's your u. So the only thing left was dx, but we had all this crap over here It's just, you just pick too much, all right? So that's okay. We start over. All right, that's all we do. We just start over. So German, I'm gonna let you try again. Pick something else.
Just 3 minus x.
Yeah, let's just go with 3 minus x. Now, German, in your mind, just as you're picking u to be 3 minus x, what's the derivative of that?
Just 1.
-1, right? -1. And now I'm going to do that step where I multiply both sides by dx. So German, now what you have is you're calling the 3 minus x your u. Okay, so that yellow part's off the table. The only thing left over here is you have dx, right? But look at your derivative here. You have dx right there, but we have a -1 over there. And we don't want a -1, right? We're trying to match this up. So, German, what could you do to get rid of a -1 on that side of the equation?
We could just multiply it by a negative.
Yeah, we'll just multiply both sides of this equation right here by -1. We get negative du equals dx. And now we have a perfect match for dx.
Yeah.
Okay, so we're going to rewrite the integral now. So German, here's the integral. You tell me what goes in here.
We can write 3 minus x. Or
Which you're calling, what did you call 3 minus x though?
u.
U, okay, so u
minus du.
Okay, and then times negative du. Now you're missing something, German. Be careful here. It was 3 minus x raised to the 10th power, right?
Yeah.
So you still need that 10th power on that u,
Right? Yeah.
right? And then you have times negative du. That's perfect. Now I'm going to do something here, German. I'm going to take the negative that's there. I'm going to pull it out of the integral and treat it like a -1. And then just put u to the 10th du. Now you're allowed to do that because I did talk about this last time. Just like in Cal 1, if you have a constant in front of a function, you take the derivative, the constant comes with you. When you're doing antiderivatives, the same way. So that negative inside, I just decided to pull it out as a -1. And then what we'll do is we'll just focus all of our attention on this. So now, German, you just have a power function, right? U to the 10th power. So what is the antiderivative of u to the 10th power? This is where you have to use that power rule.
Well, it's gonna be -1 times f to the times f. Or don't we put the 10th, get the derivative of the 10th power?
Antiderivative.
So it's gonna be like times 9.
No. You add 1 to the power, remember? No.
Add 1
1 over, I'm using that formula that the antiderivative of u to the n is 1 over n plus 1, u to the n plus 1, plus c, all right? So everybody here, right, all 19 of you that are here, you have to be at a point right now where you can do the power rule without much trouble. Like the more trouble you're having with the power rule at this point, it's just gonna slow you down so much. You should be able to just be like 1 over 11 u to the 11th, like done. Okay. So German, I'm not picking on you. I'm just saying, like, for your own benefit for the test that's next week, if you're not comfortable with that rule, the test can be very challenging to finish on time. All right.
All right.
So plus C.
Professor,
Yes.
if I were to write it u to the 11 over 11, is that also okay?
Oh, yeah, that's okay. The
All right.
question was, can you write it u to the 11th over 11? Yep, that's the same
Yes,
thing.
Yeah.
Yep.
Okay.
You'll see as I do my calculus, I always bring constants out front. I just always do that. And the reason why I do that, I think, is because when we differentiate and integrate and all that, the constant always kind of stays out front when we bring things down and add. So I just like to always leave constants in the front. So I'm going to write -111. Now u has to be changed back to 3 minus x to the 11 plus c. There we go. Okay, so that was good. Thank you, German. I appreciate that. So I was hoping to have, you know, someone that would pick a U that wouldn't work, because I can sit here and do these all day and I'll pick the right U every time. But I want you to demonstrate to one another how, okay, if you don't get the right U, you're going to have to try something else. And as you do more of these, you'll get better at picking the right U the first time around. Okay, it'll come just with practice. All right, let's
So I
look
have a
at,
question, sir.
yeah, go ahead.
For this particular problem, because we said we couldn't find the derivative of the something that's in there, would it technically be able to be okay to say that the derivative of it is there? It's just off by a constant because it's negative?
Absolutely. The derivative of the 3 minus x is there. It is there. It's just off by
not
negative 1. Yep, it's off by
Okay.
negative 1. Exactly. That would be
All right.
perfect to say that. Yep. If I said it wasn't there, then I apologize. I misspoke. I should have said it's there. We're just off by negative 1.
No, it's okay. That's all I wanted to ask.
Okay. All right, here we go. And we've got on the docket today here, let's see, we haven't heard from Christian in a while.
Alrighty.
How's it going, Christian?
I'm doing all right.
Good.
My original thought here would be to make U the 7x plus 9.
Okay. Is there any reason why you're thinking that, or?
Mainly because the square root of U, we can take that antiderivative pretty easily.
Okay, yeah, I like that. And the derivative of this is not that complicated also, right?
Right. We're just going to be left with a constant, which we can multiply out.
Yep, exactly. So take derivative of that, you just get 7. And then you bring your dx over. And so go ahead, Christian. You've got the 7x plus 9, that's going to be your u. And then we have a little bit of an issue. We have a dx here, and over here we have 7dx. We're off by a constant, right, Peggy? This is kind of like what happened in the previous one. So, Christian, how are you going to fix that? We don't want the 7 there.
Yeah, we multiply both sides by 1 over 7.
Good. 1 over 7 on both sides. And that'll kill off the 7 on the right. And now we've got our dx isolated. It's perfect. It matches exactly what we have there. Okay, Christian, go ahead and tell me how to rewrite the integral.
So it'll be 1 over 7 with
Okay, you want that outside? So you decide to pull that outside? Good. Uh-huh.
And then it'll be the square root of u du.
Perfect. Okay, so everyone, please realize that Christian went ahead and took that 1/7 du and just popped that 1/7 outside. All right. And then you said that this would be an easy antiderivative. How are you going to do square root of u, antiderivative?
So we could do it one of two ways, because I know at least on one of your homework videos you put 1 over 2 square root of u as a derivative, or
Oh yeah, as the derivative. Be careful. That's as a
okay.
derivative. We want antiderivative.
Well, what we could do here then is we can do the reverse power rule, where we rewrite u as u to the 1/2 power.
Good job. Yep, that's it. So because it's a square root, we'll rewrite it as u to the 1/2, and then use that 1 over n plus 1 u to the n plus 1 again.
Yeah,
Okay,
so I think it'll be
Yeah,
1
go ahead.
over 1/2 plus, well, for the antiderivative for u, 1/2
Okay.
plus 1, then u 1/2 plus 1.
And then plus c. Okay, now at this point, 1/2 plus 1 is 3/2. Right. So this will be 1 over 3/2, which turns out to be 2/3, u to the 3/2 plus c. So I did this all like in my head, all right? And then I can put that together, 2 over 21 u, which was 7x plus 9, to the 3/2 plus some constant. Good job, Christian.
Thank you.
Okay. we could check it, couldn't we? We could take the derivative. And if we take derivative, we better get back square root of x, square root of 7x plus 9. Do y'all want to take derivative or not? Yeah, I'll do it real quick. It won't take me long at all. Okay, derivative of this, first thing that happens, 3 halves comes out. So we have 2 or 21 times 3 halves. Then we have 7x plus 9. I subtract 1 from this. That leaves me a half. Chain rule, take derivative of what's inside. 7. Now what happens is this 7 and that 21 reduce out and leaves me a 3 out here. The 2 and 2 cancel, the 3 and 3 cancel, and you're left with square root of 7x plus 9. Okay, so it all works out. I know I did that fast, but all right, next one. Do, 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 do. Do, 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 do. What is that from? Do, do, do. Do, do, do. All right. Jimmy, is Jimmy around?
Yes, I'm right here.
How you doing, Jimmy?
Good. How are you?
Is this making sense so far?
I think I'm understanding it.
Okay, I'm gonna go refill this, and then when I come back, you can tell me the U. It'll take me about 20 seconds.
Okay.
Jimmy, what you got?
Okay. Like looking at this, so there's the x over all, but we can have it on the denominator, right? Or what was the rules for it? Because so there's the x cubed, and then on the bottom there's for the denominator is 1 plus x to the 4th, and then 1 to the power of 1 to the 3rd, or 1/3, and then what I'm thinking is that like, so 1 plus x to the 4th, the derivative of that, you could get will be 3x to the 3x cubed.
4x cubed.
And 4x cubed, yes.
And you see an x cubed there.
Yes.
That sounds like good. That sounds like a way to go then. Don't talk yourself out of it. Let's do it. Let's let you
Okay.
1 plus x to the 4th. The derivative of that.
The derivative of that is 3x cubed, and 4x cubed.
Yeah, 4x cubed. Okay, standard practice here. We're going to bring the dx over. Okay, now
Okay.
Jimmy, I'm going to write down the problem again. I'm going to rewrite the integral, but I'm going to write it in a different way. And I think this helps, you know, when you're first learning this, I think this helps to write things like this. Jimmy, do you agree that that's the same?
Yes.
Just slid that x cubed out. But do you see that by doing it this way, here I've got what my u is. So that'll be replaced with u. And then I've got an x cubed dx here. And do you see that you have an x cubed dx right there? You just have a 4 that's kind of causing a problem? Okay, so how do you get rid of that 4?
You multiply by 1 over 4.
Yep, both sides over here by 1 over 4. So 1/4 du equals x cubed dx. And now it matches perfectly, right?
Yes.
Okay, so I think we're ready to rewrite the integral. Go ahead, Jimmy.
Outside, it'll be the 1 over 4.
Okay, you want that outside? Good.
And then I'm trying to look at the ones that we just did as well.
Okay.
To compare them. Let's see. Let me see. And then it's gonna be u to the. Oh wait, not u. I'm sorry. I have some. Like, I'm trying to like break it down.
Yeah, look at what we have here, right? Look what we
Mhm.
have. We have 1 over, but then this 1 plus x to the 4th, you said that that was going to be u, right? That's
Yes.
what u is. So let's just replace it. Just 1 over
1 over u
to
to
the
the 1
1/3,
third.
okay, times. Now, what about all this blue stuff here? What is that being replaced with?
That's du.
Du in the 1/4, which you already
1/4
put
u.
that, right?
Mhm.
Okay. Now, 1 over u to the negative 1/3, you could rewrite that and bring that u up to the top as a negative 1/3, u to the negative 1/3, like that. And then just use
Okay.
the power rule, right? Like at this point, you could just use the 1 over n plus 1, u to the n plus 1.
Wait, can you say it again?
So this step from here to here, what I did was just algebraically, I moved the u up to the top, which makes the exponent negative, right? But now
Mhm.
you can use the power rule, that rule that I mentioned earlier. Antiderivative of u to the
Yes.
n, du equals 1 over n plus 1, u to the n plus 1 plus some constant. So here for us, the n is negative 1/3.
Yeah, negative 1/3. So then it'll be 1 over negative 1/3 plus 1. And then u. Then it's going to be negative 1/3 plus 1 plus c.
Yep, okay, good. And now we just have to figure out what that is. So negative 1/3 plus 1 is 2/3. So this first one is going to be 1 over, I'm going to go a little slower here, 2/3, u to the 2/3 plus c. 1 over 2/3 is the same as 3 over 2. U, which is 1 plus x to the 4th, I'm replacing it now to the 2/3 plus c. And last step would be 3 over 8. Just put those fractions together, multiply them. There we go. Jimmy, that okay?
And then,
I kinda
and then
took
to
you
make sure that it's right, you just have to get the derivative of that, right? And then it
Yeah.
should bring it back to the original.
Yes. Now, I'm not going to require you do that, okay, on the test. But if you get to the end of the test and you still have time and you want to go back and check some of your answers, you can. As time goes on, though, and these problems get more difficult, it just won't be worth it for us to go back and check them. All right, any questions there? Okay, that was good. That was good. That went okay. Let's do the next one.
Hey, Professor, I had a quick question.
Yep.
Sorry, I was gonna say this to the end of class, but I figured I might forget, so I just thought I'd ask it now.
Mhm.
Since the exam was moved to Wednesday, does that mean the homework assignments are moved to Wednesday too?
Yeah, I might have to change those online. Well, you know what? Yeah, because they're all due on the exam day. I can push those out.
Okay, thank you.
Also, you know what? Now I think about it, after the due date, you can request an extension and the system will give you an extension.
Right, I think I was talking to you about that last class.
Yeah. Yeah, so don't worry about that. If you have to request an extension, it's going to tell you there will be a 10% penalty. I'm not going to penalize people. So don't worry about it.
Thanks, Professor. Appreciate
Yeah.
it.
No problem.
We could do them on pencil and paper, right?
Oh yeah. Uh-huh.
That's what I've been doing.
Yeah, remember the homework is totally just for your own benefit. So, you know, I'm not collecting it. I did say that at the end of the semester, if you're right there in between like a C and a B or a B and an A, and you're talking about, is there anything I can do to get, you know, one more point? I'll be like, can I just see all your homework? And, you know, that might help. All right. Who is up here? We have now Alex. Alex.
Yes, sir.
How's it going? Here's
Going
your
good.
problem.
Oh, which one? There's two of us.
Oh
Two.
yeah,
Oh, yeah.
sorry. Yeah, there is. Alex Pohl. Sorry. It was, yeah.
Okay.
Cool.
We'll get the other Alex in a little bit. Maybe.
All right.
So I'm gonna go ahead and say the u should be 5x plus 2.
Okay. Let's try it. All right. Derivative of that with respect to x will be
5.
5. Okay. Bring our dx over. Like that.
Yeah.
So
And
u
then,
is going to be
to add-
that.
Yeah.
Go ahead.
Yeah. And then we can multiply by 1/5.
Yep. I think this one's working out pretty nice, isn't it?
Yeah.
Okay, go ahead. So what's the new integral?
So it'd be, can we put the 1/5 out to the front?
Uh-huh.
All right, cool. And then e to the u
Yep.
times du.
Du. Okay.
Yep.
And now you just look at that and ask yourself, you know, do you know the antiderivative of that?
Isn't that just eu?
Yep. That's itself. Uh-huh. Plus c.
Yeah. Then you just replace the u with the.
Replace du and we should be done.
Coo-coo-coo-choo.
Yep. That was pretty straightforward, just as long as you knew what the antiderivative of e to the u was, which you did, which is good.
Can you put the e over the one over the
Yep.
5?
Yep. Okay. I'm going to make one up. These have been too easy. You ready? Hold on. This should be fun. All right. So I'm going to call on the next person here. I was going to have volunteers, but a volunteer is probably going to see it. So I want someone to just randomly see if they can get it or not. So is it Varun? Varun? Am I saying that right?
Yes, sir. It's Varun.
Varun, okay, it's you. I'll give you a minute to look at it.
I think I'm gonna go ahead and give it a try and see.
Okay.
My best guess would be the denominator, although I don't know if that's too much to put for you.
You want to try it?
Yeah, sure.
You want the whole denominator? I'm not trying to talk you out of it. I just want to be clear that that's what you want to try. But let's try it. Let's try it. Okay.
Okay.
1 plus cosine squared of x squared is our u. All right. So we're hoping to see its derivative, right? Somewhere. Let's take its derivative. All right. So Varun, the derivative of 1 is gone, right? 0, right? But you still now have to take derivative of this. And let's just all make sure we understand that is cosine of x squared, all of that squared. That's what that notation means, right? That squared right there really means a squared on the outside of the whole thing. So if you had to take derivative of that, Varun, what would you do first?
Would that be chain rule?
Yep, chain rule. So Start with the 2 on the outside, the squared, right? Bring that
Right.
out. Cosine of x squared, all of that now raised to the first power, right? Times, now you've done the squared, so Varun, now what do you need to take derivative of?
The inner part cosine x squared.
Okay, so the derivative of cosine of something is
Would that be
negative,
sine or negative
negative
sine?
sine of x squared, right? So we've done the cosine. Now you have to do derivative of what's inside there, which is
2x.
okay. So now let's just go back and see if this was a good choice for our substitution. We chose the entire denominator as u, right? And now we're hoping to see its derivative somewhere. Here's the derivative. Do we see that somewhere? Well, I see x sine squared x. That kind of matches up a little bit with this sine x squared, and then like it's kind of that, isn't it? A little bit. It's off a little bit. But all this I don't have, right? That's a question mark. Like, where is that? That does not appear anywhere over there, does it? Do you agree? It seems like maybe we got too much there. Like we grabbed too much. Is that a fair assessment? Does everyone see that that's too much?
Yes, sir.
Okay. All right. I wanted to go down that path though. I wanted us to explore that. I wanted everyone to see why that wasn't going to work. Come on, go. All right, so this is what I was talking about. Persistence, right? Persistence. You got to be able to, I would never, when you're doing your homework problems, I would never work through a problem, realize that it's not going to work, crumble up and throw it away. I think I've said that before. I wouldn't do that. I would just exit out and then work the next problem below it. And that way, if you ever want to go back and review, you can kind of like go through and see the things that you did wrong. And that way you're kind of like, okay, I don't want to, you know, I want to avoid that now. It's up to you. That's just my advice. All right, Varun, do you want to keep going? You want to try something else?
Yeah, I think I want to try the sine x squared.
As your u? Yeah. Okay. Is there a reason why you want to do that? I'm just trying to get into your head here a little bit.
I'm hoping that when I take the derivative of it, it would give me something to replace the cosine squared x squared with in terms of u.
That seems like a fair analysis. So derivative of sine of something is cosine of it, but then times 2x and then I can bring the dx to the other side. All right. Is that okay, everyone? Varun decided to make the substitution u is equal to sine x squared, and then I took the derivative using chain rule, and I brought the dx to the other side. So let me highlight some things. This is our u, so we're not allowed to look at that anymore. And now, do we have this derivative somewhere in there?
We kind of have it.
I mean, I see what you were thinking. You were trying to get this cosine x squared, and I see it right there, right? But what's wrong with it being there?
It's cosine squared, not cosine x squared.
Okay, so that the fact that it's squared, it doesn't match. But more importantly, it's in the denominator. And we don't want the derivative in the denominator. We want the derivative never to be in the denominator. We want it to be up top so we can move it around. So not quite sure that's going to work.
Could you multiply the denominator by 1/1? So like 1 plus cosine squared, or would that change it at all?
You could, but I think it's going to make this more complicated because then you'll have a new expression up top. More likely, your better bet is to try a different u than to try and do some algebra that's going to force this one to work. Okay, all right, this is good, this is good. So Gotta be willing to take some swings, right? We'll call that one a foul ball. All right. So you've got one strike and one foul right now.
I'm not too sure what else to use for a U. I mean, I think X might be like I don't see how X would really add anything to the equation. And we already tried cosine squared X squared. Would you just maybe do it as a denominator?
Think of like the most simple thing that you can see here. And let me just say one thing. When you're doing U substitution only, never make a substitution U is equal to X. Okay? If you do that, you're going to wind up rewriting the whole problem and just replacing all your X's with U's, and you'll be exactly in the same spot. Okay? So you always want to do something a little more complicated than just X. So, Varun, don't go so complicated with your U. Try something just very simple. Do you see something in its derivative?
I'm not too sure, Professor. My best bet was going to be sine X squared, and I thought we could have done something with the derivative, but I'm not too sure now.
Okay.
Can
I'm not letting you off the hook. You gotta try something, right?
Yeah, that's true. Could I maybe ask my classmates if they could help me out?
You want a lifeline? Okay.
Yeah.
I'm gonna give you a hint. All right. I'm gonna give you a hint. Look at this right here. That X is the derivative of what?
Would that be the derivative of X squared? It'd just be 2X.
Yeah, it'd be off
right?
a little bit, right? Do you see X squareds in there?
Yeah, sine X squared and
Let's
cosine
just start
squared.
with that then, right? Because remember I said think real simple, okay? So do you see now that if you let U be X squared, that you do have its derivative? It is there, it's off a little bit, but it's there, yes?
Right.
Okay, so let's do that.
Oh, I didn't know you can make it the thing inside sine and cosine.
Oh, sure. Anything you see, you can replace. So derivative of that is 2x. And then you bring the dx to the other side. And so watch this, Varun. I'm going to rewrite the problem again. This is just to help everyone see what's happening here. All right, so we're going to replace that x squared and that x squared right there with u's. We need an x dx. We almost have it. So Varun, how are we going to make that work?
We would divide the 2 by 1/2 and put it outside the integral.
So we're going to do a 1/2 on both sides here. And that'll give us our x dx. So now they match up perfectly. And that seems like we're getting somewhere. Do you agree?
I agree. That's a lot more than we've gone with the other 2 U substitutions.
Okay, so let's just rewrite the integral. So Varun, go ahead. I'm going to let you tell me what to put here.
So would that be 1/2 outside the integral, then sine of U
Yep.
on the numerator, and then for the denominator, would it be 1 plus cosine squared U?
Yep.
And then outside that fraction, it'd just be du.
Perfect. Okay. So do you agree, Varun, that we have made some headway here?
Yes.
But you look at that right now, and you probably look at that and go, I don't know how to find the antiderivative of that, though, right? It's not,
Yes.
It's not something real simple. Okay, good. All right, you're off the hook. All right, I'm going to let good job. That was perfect. That's what I wanted everyone to be able to see, is that this is about persistence. This is about trying different things and then having those little moments where I go, oh, I didn't realize that. Oh, that worked out better than I thought it was, right? Okay, so Michael Sandoval is up. Michael around? Let's see, Michael. There you are, Michael. Okay, so you get to pick up now where Varun left off. We have a new integral. It's a little bit nicer than the one before, but can you do anything with this?
Would we want to try and find like the relation between sine of u and 1 plus cosine squared of u? Or
You mean like some like pre-cal trig identity or something?
yeah,
We could maybe mess with that. But how about you just start the whole thing over? I mean, just
okay.
this is oh shit. This is a new problem.
Oh, so okay.
So do you see
Find
something in
another
its derivative? I didn't hear you, I'm sorry.
So okay, let me see. Trying to look at my notes to see.
Yeah, it's fine. So what I'm suggesting for Michael here is that we try another substitution. We do it again. So Michael,
can we make,
go ahead. Go
Can
ahead.
we make the u
Drum roll.
sine?
Okay, so if I do that, the derivative that's cosine, but where would it be? Where would that cosine be? In the denominator, right?
Yes.
You don't want that, but you're close. You're close though.
Okay. Could we try cosine?
There you go.
Yeah.
So if you let u be cosine, its derivative would be negative sine, which you have, you're off by a constant, right, Peggy? And it's up top, which is good, right? Okay. So we're going to make another substitution, but we can't use u because we already used u, right? So we get to use another variable and you get to pick. It's up to you. Not x and not u.
Okay.
Right? X is the original problem. U is the first substitution. And what do you want?
Can we use like y?
We could do y. We could do y. We can do anything really. I'll do y because that's what Michael wants to do. I usually use v or w. And that's what, but I'm going to use y. So y is equal to cosine of u, right? Now, this is a little bit tricky here. Pay attention to this. I need to take derivative, right? Just like we did before. But this is going to be d what, d what. We're taking derivative of, say again?
dx dy?
Nope.
Okay.
Look at what we did up here. When we had u is x squared, we took the derivative of u with respect to x, right?
Yes.
So here we're going to be taking derivative of
y with
respect to u.
Okay.
And that should be negative sine of u, right? Then we're going to multiply both sides by du. And man, things are going to start to look real good here. Cosine u is right there, right?
Yes.
And then we need a sine u du. We have sine u du, but we're off by a sine, aren't we?
Yes.
So we just multiply both sides by -1. And I think we can rewrite the integral now. So Michael, you wanna go for it? What's the new integral going to be?
Okay, so we have nothing to put outside the integral, correct? Or,
well, you have a -1, right?
okay, we put the -1 outside the integral.
Okay, so this is now going to become -1/2 because we already had a 1/2 out there, right? Integral. Now all that blue stuff, right? All the blue stuff, sine u du is really going to be the negative dy. The negative went out. So the dy, I'm just going to slap it on the outside, right?
Yes.
But what's
So,
still here?
Um,
What's still here?
just the 1 plus cosine squared of u.
Yes,
Over
on the
one.
bottom, right? On the bottom, it's 1 over.
Yeah. Right.
I'm just rewriting the original problem.
Mm-hmm.
Kind of peeling out that sine u du. So you said it'd be 1 over 1 plus what?
Let me see. Cosine squared u.
It was cosine squared u, but we
Oh,
replaced
sine.
cosine u with y, so it'll be y what? It'll be y what? Sorry, Michael, I didn't hear you.
Sine.
No, we're doing the yellow here. We're replacing the yellow with y, right? But we still
Yes.
have the squared, don't we?
Uh-huh.
So this will be y squared,
That's right. Mhm.
okay? All right, drum roll. Who knows that? Anybody? Antiderivative 1 over 1 plus y squared.
Well, couldn't it just be the inverse tangent?
Inverse tangent. The antiderivative of 1 over 1 plus y squared would be inverse tangent of y plus a constant. So from here to here, I'm using the formula. Well, I gave this to you already, right? But this is actually formula 17. This is the one I put all those stars next to and said, don't forget this, this will come up, right? All right, good job, we're not done. But we're gonna move on to Sarah. Sarah here? I see Sarah. Let's see if Sarah's available.
Yes, I'm here.
Okay, Sarah. This problem's fun, huh?
Yes.
Okay, so now my answer is, or our answer is -1/2 arctangent of y plus c. But our original problem was in terms of x.
Yes.
So the first thing we have to do is get everything back to, we have to try and get everything back to x. So Sarah, what do you think I should do with this y that's in here?
Place it with the cosine u.
Replace it with cosine u. And then I should go into that and replace the u with what?
X squared.
X squared. Okay, so I just substituted back what was y, okay, then what was u? Got it. Bam, there it is. Shall we check? Sure, I'll check. So I take derivative of this, -1/2's out front. The derivative of arctangent of something is 1 over 1 plus whatever the something is, squared times, I've done the arctangent. Derivative of cosine of something is negative sine of that something. Okay, done. Take derivative inside 2x. Okay. -1/2 and the 2 and the -1/2 go away. All that cancels, and what you're left with is an x and a sine x squared on top, and you're left with 1 plus cosine x squared squared on the bottom, which is the original problem. Okay, so we had to do that with 2 substitutions, right? Now, I will give you a little pointer here. Had you started this problem, you could have, at this point right here, made this u substitution right there. In the very beginning, if you would have made your substitution u is cosine x squared, this would have worked with 1 substitution. Because the derivative of that is negative sine of x squared times 2x, which you basically have right here. And that gets replaced with u. And there, at the next step, you'll be 1 over 1 plus u squared du. You'll have some constants to worry about. But do y'all see that now? Do you see how, in retrospect, you could have actually gotten it if you just, if we would have got the u to be correct? So just to give you some idea of the comfort level that you're trying to get to with this, right? So I just made that problem up, right? I didn't go to a textbook or anything like that, right? I just wrote it down. And of course, I'm teaching this, so I should have a comfort level, a real good comfort level. But I had to make sure everything worked out, right? So I knew that this was going to be an arctangent problem. So the way I made up the problem, I want you to think about it, okay? Because I'm gonna make up another one the exact same way. And sometimes when you think about how I'm making it up, you'll understand like how to undo it. So I'm gonna make up a problem right now where, check this out. I'm gonna do the exact same thing. It's gonna be an arctangent. So I'm gonna make that piece in there, instead of the cosine, I'm gonna make it natural log of x. So the derivative of that's gotta be somewhere, right? What's the derivative of that? What's the derivative of natural log of x?
1 over x.
1 over x, right? So I would need a 1 over x out here. Do y'all see what I'm doing? Okay, but if I were making up this problem, here's how I would do it. Oh, see, do you see how shitty that got real quick? Because I distributed that x through the bottom. Now you look at that and you're like, what the hell do I do with that? But this is just u as natural log x, right? Okay, we're not gonna work through this problem, but I'm just trying to get you to see how you could cause some issues. All right, let's go back to the problems that they gave us. How are we doing on time? 12:03. Maybe we can just talk about these for time's sake. How about Christopher? Christopher V.
Hello, sir.
How you doing?
Doing pretty good.
Okay, look at number 7. Let's see if maybe we can just get the U's correct for these. And then I can leave the work to you. So Christopher, do you see on number 7 what we could use for U?
ln x.
Yep, U is natural log of x. Because the derivative of that is 1 over x, right? Which you have there, don't you? This integral is really sine of natural log of x times 1 over x dx. See, the way I peeled that 1 over x off to the side, it makes it a little more obvious. Okay, good. I'm not going to work through that. That is the correct substitution. Christopher, you did so well on that one. How about the next one?
Sure. Is it possible that we could, I don't know what, I don't remember the term for it, but do something with the quadratic equation on the bottom?
Oh, like factor it or something, or we could do something like that, but, and we will. It's just not going to be in this section. This should go with a basic substitution. So, you know, this one might be worth doing the whole way. Just take a shot. I'll let you off the hook after you just give me a U. Right or wrong, I'll let you off the hook.
The u can't be the x squared plus 4x minus 3, can it?
It can't? Why?
Because it's in the denominator.
No, the u can. The u can. The derivative can't.
Oh, the derivative can't.
The derivative can't. The u can be anywhere.
So let's make the u x squared plus 4x minus 3.
Let's do it. That is the correct substitution. All right, Christopher, I'm going to let you off the hook, and we're going to now ask for some guidance from Yusuf. Is Yusuf here?
Yes, sir.
Okay, there you are, sir. Okay, Yusuf. There, we got the U. So du here is going to be what?
It's going to be 2x plus 4. We're just going to be off by a constant, but we could scale that.
Notice real quick, everyone, this step to here, I'm from now on, I'm going to stop writing du over dx. And I'm just going to write du, and I'm going to put the dx on the other side to save myself a step, because I'm going to do that every single time. All right. So just now that we've done it so many times, let's just make our lives a little nicer. Okay. So Yusuf, you said what now? We're off by a constant?
Yes.
So you're seeing this 3x plus 6 dx. Somehow this over here has to become that, right?
Mm-hmm.
Okay, good. So how are you going to make this thing become that?
We would have to scale it.
Okay.
See. Best way.
Yeah, that's why I wanted to do this one. This one's a little bit weird. But can I give you can I help or no?
Oh, please.
Okay, so look, check this out, everyone. On the original integral, could we have pulled a 3 out of the top? Is that legitimate algebraically? Factor a 3 out of the top and just pop it out of the integral? Right? All I did was I took this, and then, you know, from here, these two, and then I just pop that 3 out. Yusuf, does that help at all?
Yes. Now all we have to do is just multiply du by 1/2 or scale it by 1/2.
Exactly. So all we have to do is multiply a 1/2 over here, and then a 1/2 over here would give you x plus 2 dx, and that matches this no longer. That matches this. Ah, shit. Excuse me. Pardon me. Right, now they match. So pulling that 3 kind of helps us a little bit. All right, Yusuf, you want to tell me what the new integral becomes?
The new integral is going to be 3 over 2.
3 over 2, because you're going to go ahead and pull that 1/2 out. Okay.
And then it's going to be 1 over u du.
Du. Okay, good. So everyone, he just did this. Yellow was our u, and because the blue stuff's off to the side, he wrote as 1 over u. And Yusuf, you okay with the antiderivative of 1 over u?
Yes, it's natural log of the absolute value of u.
Yep, natural log of the absolute value of u plus c. And now just replace u with Christopher's substitution plus c. We're done. Check it if you want. Check it if you want. All right. All right, let's just let's take a little 1-minute kind of breather here for a second. What do y'all think? How are y'all feeling about this? Feedback. What do you? Go ahead. Anyone have any comments?
I feel like with a little bit more practice, I'll be ready for the exam on Wednesday.
I think you can, I hope that you can see that. Sorry, I took my video off because I got something in the background right now. The way to get good at this is practicing. So this isn't like in college algebra, you're taught the quadratic formula, right? And then you do it like 2 times, 3 times, you're like, yeah, I got it, you know? Like, yeah. This is something where every problem is unique. Everything is different, and the only way to get good at it is just practice, practice, practice. Are we ready for another one? I'm going to write it down. I'm going to let you all look at it. And all right, so let's take a minute. I'll give everyone a minute, and then I'll take a volunteer.
Mine too. I don't know why that like. Go get a pedicure.
Okay. Who's going to volunteer?
I guess I will.
All right, Peggy. Let's see. I'm going to mark you for today for volunteering. All right, go ahead. What do you got?
So far, what I was trying is setting u to 2x plus 1, and when I took the derivative, the derivative of it, I got that it just equals 2, I believe.
Yes.
And that's there. It's just off by 1.
Okay.
2 dx, and then to get dx by itself, I just multiplied by a half, so it's 1/2 du equals dx.
Okay.
And that's about as far as I got.
Okay, so is that as far as you got, like ran out of time, or is that like you're kind of?
Yeah, that's when I ran out of time.
Okay. All right, well, then let's see. I mean, this looks okay. You got 2x plus 1 there. That's going to be your u. The dx, you've got a perfect match for dx. Dx is going to be replaced with 1/2 du. So Peggy, what's still an issue here though?
The x. That's exactly why I got stuck.
Okay, so does everyone see that that x is a problem? Right now, if we replace things, here's what we would have if we started to rewrite this. We'd have a 1/2 out here. We'd have the du here. We would have u to the 100th power, but then we would have times x. And that's no good because we're trying to get the entire thing in terms of x. I mean, sorry, in terms of u, not x. So we still have to resolve this x. So Peggy, is there anything that you know about x? Do you have any relationship between x and u? Anything that connects the two together?
If you go to the u equals equation, you could arrange it to where it's like x equals something.
Perfect. Solve that for x. Good. So I'm going to move 1 to the other side by subtracting. And then isolate x by multiplying both sides by a 1/2.
Yes.
And look at that. Peggy just actually came up with an equation for x using the substitution that she made earlier. So I'm showing this, this is the first time this has happened. Okay, this is why I wanted to show you the problem, all right? We made a substitution, everything looked great, but then we still had an x that we couldn't take care of, but using this information, we can. So Peggy, if we rewrite it now, 1/2 integral, the x now becomes the 1/2 u minus 1 times u to the 100th power du, right?
Yeah.
Now, Peggy, is that any better than what we had before?
Well, it is. There's no x's.
There's no
And I think
x.
you can move the 1/2 to the outside.
Okay, so I'll put that out
So
there.
it'd be 4th, yeah.
4th, okay. So this is a critical moment in the problem. I'm going to do that, and I'm going to say versus the original problem. There was the original problem right next to it, and there's the new problem. So Peggy, is the one on the left that you've generated for us any better than the one on the right?
Not really.
Look harder.
Couldn't you do another substitution or something?
We might be able to. It's not that hard. It's not that much. We don't have to do that much. Think algebra. Just basic algebra.
No, I have no idea.
When I show it to you, you're going to be like, oh yeah. Distribute.
Yeah, could distribute.
Right. Could you distribute this u to the 100th through this parenthesis?
Yeah.
Right. And if
So
we
it'd
did that,
be,
go ahead.
I think it would end up just being u to the 101, right? 101 minus u to the 100.
Okay, good. Now, these two terms are separated by subtraction, right? So you can do them
Yes.
individually using the power rule.
Mm-hmm.
So that's doable, right? Like we're good here. Now, Peggy, why couldn't we not do that in the original version of the problem? Why could we not?
I'd say you could, but it would just not make things easier.
Order of
Because
operation.
then you would end up with like 2x, you'd end up with like 2x cubed plus x to the 100th power.
Yeah,
So
it
it
would
just kind of make things
actually be,
messier.
the order of operations would not allow that distribution to happen. Like you can't, order of operations, this is multiplication, right? And this is exponents. You have to do exponents before you do multiplication. So in order to do the original problem, you would actually have to do 2x plus 1 times 2x plus 1 times 2x plus 1
for 100 times.
And then get that polynomial all expanded and simplified. And then you could distribute x through, right? But with this substitution we made, we're actually able to change things in a way that this right here did not have a power on it anymore. So we could pass it through, right?
Mm-hmm.
All right, let's finish it. I just want everyone to see why this is working and why we didn't just stick with the original problem. So this is going to be 1/4. Now we have to do those individually. And Peggy, I'm going to let you off the hook because you volunteered. Thank you very much.
Right.
Let's see. Ross? Is Ross around?
Yes, sir.
Okay, Ross. Antiderivative of u to the 101.
Would that be 1 over 102 to the u to the 102?
Yep.
Awesome.
Okay, u to the 102. And then what about the next one? Minus?
Yeah, it'd be minus 1 over 101 times u to the 101.
Plus c. Now you notice, Ross, that I did the plus c off to the side, but I still have that 1/4 out in front and everything in parentheses.
Mm-hmm.
Okay. All right. I have had students ask me before, does that 1/4 need to pass through to the c?
No.
And the answer is no, because 1/4 of a constant is still a constant. Like,
yeah,
it doesn't change it. Okay. So now, Ross, what we want to do is replace our u's, right?
Mm-hmm.
So, and I'm actually going to multiply the 1/4 through.
Okay.
1 over, what is that?
That's 408.
408. And then u is, I forgot what u was.
2x plus 1.
2x plus 1. So the 102 minus 1 over 404, right?
Yeah.
And then 2x plus 1 would be 101 plus c. There it is. That's the antiderivative, we think, right?
Yeah.
We could check. I will. Okay, if I do this, I'm gonna do these separately. Okay, 102 comes out. When I do 102 over 408, I get 1/4. And then I get 2x plus 1 to the 101. I subtract 1 from the power, but then times 2 because the chain rule, the derivative of the inside. Minus, then I bring the 101 out here, and I get another 4th. And then I get 2x plus 1 to the 100th. And then I get times 2 because of chain rule. Okay, the 1/4 in this, that becomes a 1/2. Then I got 2x plus 1 to the 101, and then minus a half, and then 2x plus 1 to the 100th. Wait a minute, that doesn't look like the original problem. Oh, but it is. Okay, so now I'm going to factor out of both of these 1/2. They both have a 1/2. They also both have 2x plus 1 to the 100th power. Do you all agree with that? They both have that. So I factor that out. What's left in the first one? When I factor that out of this, what am I left with?
2x plus 1.
2x plus 1. Okay. And then what happens when I factor out this thing from the second one? What am I left with?
-1.
-1. Okay, these ones cancel. And so I'm left with 1/2 2x plus 1 to the 100th power times 2x. And these 2's and the half cancel, which leaves me with x times 2x plus 1 to the 100th power, the original interval. Pretty awesome, huh? All right. We're just having fun now. It's relative, right? Fun is relative. Give me a second. I'm going to look at my old exam here. Oh, yeah. Yeah, that's a fun one. Okay, so I'm going to give you something similar. Hold on, I have to really make sure this is going to work. Okay, I'll just keep it simple. Give you a minute to think. Do, 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 do. Do, 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 do. Okay. Any volunteers?
I can go for it.
Okay, go for it. What do you got?
I would first separate the x cubed into x times x squared in the original problem.
All right, so now you're confusing us. Why are you doing that?
Because there's a x squared at the bottom.
Okay.
And, when you take a derivative, you'll get the x.
Okay, so I'm trying to get your logic here so that everyone follows this. This is going to be correct, but it's definitely not a natural move. Okay. So were you looking at the denominator? Were you looking at the x squared or 1 plus x squared?
1 plus x squared.
So you were thinking you wanted to let u be the 1 plus x squared, but then the derivative of that would have had to have been 2x, right? And you have x cubed up top, but then you realize x cubed could be ripped apart as x times x squared, and that would give you that x you're talking about, right? Okay, so that's the logic that Yusuf is using here. 1 plus x squared, derivative of that would be 2x dx. And then Yusuf said, okay, I'm going to rewrite this. I'm even going to write it a slightly different way.
To 1/2 du.
Okay. So Yusuf was saying that x cubed becoming this x times x squared will allow you to pop that x out, and that would take care of at least this part of the problem after we scale it by 1/2. Does everyone follow that? Although it's not very like intuitive in the very beginning, that's not intuitive, but now that you see it, do you see that might work? This might work? Okay, what now, Yusuf?
Now what we do is we will solve for x squared pretty much.
Okay, so this is kind of like the problem that we just did a second ago, where we had used the equation that we started with. See, because when we go and do our substitution, we know the denominator is going to be u. We know that this x dx is going to be 1/2 du. We still needed to figure out what this x squared was going to be. So we're just going to take this equation and solve it for x squared. Just subtract 1 on both sides. So now we know what the top's going to be. You want to go ahead and tell me what the new integral is, Yusuf?
Yes, sir. It's going to be u minus 1.
U minus 1, that's the x squared. Over
u.
Okay. And then the blue part?
Du.
Du. And then we have the 1/2, right? Because you did scale it, so we'll just pop that out. There we go. All right, what would you do with that, Yusuf?
Now you can go ahead and separate those into u over u.
Yep, u over u minus 1 over u du, and of course u over u is just 1.
And that will become natural log of u, or absolute value of u.
So now the antiderivative. What's the antiderivative of 1?
X or u.
U. So everyone keep in mind here, the antiderivative of 1 is u because it's with respect to u, then minus the natural log of the absolute value of u plus c. And last step is just to replace u with what it was. So u is 1 plus x squared. Any questions?
Where did the u minus 1, what happened there, sir? I got a little lost there.
Where did it come from?
Yeah.
This came from the fact that we were trying to figure out how to replace the x squared. We knew the yellow would be replaced with u. We knew the x dx would be replaced with 1/2 du. So we had the blue and the yellow taken care of. We just didn't know what x squared would become. So Yusuf said, hey, go back to the original equation. Here's x squared right here. Just subtract 1 on both sides. And when we do that, we get that x squared is u minus 1.
Oh, yeah.
And then we took that and replaced that when we rewrote the integral.
Okay.
There it is. Good. That was actually a test problem. Let me look at some of the others I have here. It was a pretty straightforward test. Okay. See if I can come up with another one here. See, we've got about 9 minutes left. Okay, how about this? This one isn't necessarily harder or anything. It's just kind of something I just popped up in my head here. So let's see. Jorge?
Yeah. So what I'll do is let's see, U will be S2x. I guess my U will be 1 over x.
Okay. What's the derivative of that? So it might help if we were rewriting. Oh, go ahead.
Oh, my derivative, I guess, will be a -1.
Not quite. You bring the -1 out front.
Yeah.
And then you subtract 1 from the power.
Yes, it'll be -1x, so it's -2.
-2, right? dx. Now, do you have that? Because
No.
you need to have that there.
We need to have it.
Jorge, couldn't I rewrite this as -1 over x squared though?
Yeah.
Do you have -1 over x squared?
Well, you don't, but you could make it.
Yeah. So we actually do have an x squared on the bottom, don't we?
Yeah.
So we could go like this and rewrite this like that. Just slide that x squared out. And now this matches with this almost. We're off by a sign, right?
Mm-hmm. So you divide the -1 and move it to the other side. So it'll be negative du equals 1 over x squared dx.
Okay. Good. And now it matches perfectly. So I think it's rewrite integral time, isn't it? 1 over x is going to be the u. So what would the new be?
Negative integral.
Uh-huh.
That's secant u tangent u times du.
Yep. All right. And Jorge, do you know the antiderivative of secant u tangent u?
Wouldn't that be secant squared? No, it would be yeah.
Just secant u. So minus secant u plus c. So go back to Cal 1, derivative of secant x is secant x tangent x. So obviously the antiderivative of secant u tangent u would be secant u. And then we have the negative out front. And we throw in the u. The u was 1 over x. We're done. Good job. Okay. 12:35. So, yeah. Let me talk about the test, which again is not until a week from today, right? So next Wednesday. I'm just going to verbally tell you, I'm going to verbally share with you the things that I asked, just to give you an idea of the number of problems and stuff like that. So there were 10 problems and a bonus on the last test I gave. This one was in fall of 2018. So the first problems involved taking derivatives involving inverse trig functions and inverse hyperbolic functions and hyperbolic. So, you know, remember we went through all those new functions and their derivatives, right? So you have to be able to use the chain rule to take derivatives of these new functions, right? And that was one problem on the test, but there were two parts to the problem. So there was a part A and a part B, where I just asked for derivatives, okay? The next problem, now I'm not saying your test is gonna be exactly like this, okay? This is to give you a feel for what to study. The next problem I asked, I gave the second derivative of a function. I said, here's the second derivative of a function. And I gave two conditions, initial conditions. And I asked for the class to go back and get the original function. So I gave f double prime and I said, go find f. And I had to give them two pieces of data to do that. So this is a lot like that acceleration problem where I give you acceleration, you go back to position. Now, in the problem I gave them, they had to solve a system of equations. So I did show you all that is possible. After that, the rest of the test is integration. So the next problem involved power rule. So that's just making sure students knew how to use the power rule. And then problems 4, 5, 6, 7, 8, those were all U substitutions. Yeah. And then 9 and 10 involved the next section, 6.1, integration by parts, which we will talk about on Monday. I'm probably gonna, I don't know if I'm gonna include it on the test. If I do, it will be a very basic one, but we'll talk about it. Let's see how Monday goes. Because the integration by parts problems, they can be easy and they can be hard. If anything appears on the test next week with integration by parts, it'll be the easier of the types, okay? And then there was a bonus problem which, yeah, it was not hard. It was a basic U sub problem, but the U sub was not easy to figure out. Okay. So does that help a little bit? Just give you an idea of like how much from each thing to really worry about? I mean, really you need to be making sure you understand the power rule and making sure you understand U sub and practicing. Any questions or comments or anything?
I know in the homework there were some related rate questions. Would we expect to see any of that in the first exam?
I don't think so, because the only positive part of a related rate problem right now for us in this class is just to show how you can use the inverse trig functions to do related rate problems. I'm trying to get everyone here geared towards antiderivatives at this point. That's my main emphasis.
Okay.
Any others? Okay, well, in that case, 12:40, I'm actually finishing on time today. Make sure you do your homework, practice, and hopefully it goes good for you. Remember, if you're gonna watch my homework solution videos, try not to just watch my video. You go try and figure out the U, right? Because if you just watch me figure out the U, it's not gonna help you. All right. Have a good weekend. Well, one day, right? That's it. We're done. So have a good weekend, and I will see you on Monday. Get ready for that test on Wednesday.
See you, sir.
All right. Have a good one.
Have a good weekend.
Bye, Professor. Thank you. Have a good one.
You too.
Bye, thank you.